point, you should get a message that it's recording by now.
Yes, I confirm.
Okay. Let's start. I'm talking right now, so I would start. Welcome to our webinar 3 in the Renaissance webinar series. The title is Handful Tools for Future Local Energy Community Members. What we will tell you here is what CERTH and CIRCE did in the Renaissance project, and yeah, we also will tell you who we are and what our goals. So we will start with a short tour de table, so you can have an idea who is here now. I am Hans Blutzowait from the CIRCE Foundation in Spain. Later we'll explain a bit more what CIRCE is. I am one of the technical collaborators from CIRCE in the project, and I'm here with two colleagues of mine. Please, Juan and Gonzalo, just present yourself.
Hi, hello to everybody. I'm Juan Almajano from CIRCE, and we are going to explain a little about the CIRCE's Living Lab and how it's implemented. It's just like a virtual demo use case. I expect it's grateful for you.
Hello,
Thank you.
I am Gonzalo Orne, and I am from CIRCE Foundation also as my colleague. And later we're going to see also the user interface for this project.
Thank you very much. So now, please, from CERTH, just present yourself quickly.
Yes, hello. I'm Aristotelis Pliotis from CERTH. Along with my colleagues, we have Petros Iliadis, Renos Rotas, Nikos Katsaros, and Zoe Boutopoulou. They will present themselves shortly. We all represent different institutes of CERTH. I'm from the Hellenic Institute of Transport, and we will present more about our organization a little bit later. So my colleagues, Renos, Petros, or Nikos, if you can shortly present yourself.
Yes, of course. Hello, everyone. My name is Renos Rotas, and I work for the Chemical Process and Energy Resources Institute of CERTH. And I'm going to present you later on our work regarding dynamic simulations of two energy communities in the context of the Renaissance project.
Yeah, hello everyone. This is Petros Iliadis. I am a colleague of Renos Rotas in CERTH Sphere. I hope you find this webinar interesting.
Hi everybody, this is Zoe and Nikos from CERTH IPI. We're going to present ourselves and the work done in the Renaissance project in a few slides from now. Happy to be here.
All right, Hans, I think we can move on, and we will present more later through the presentation.
Okay. We are working the Renaissance project. We are part of this consortium. You see here are quite some people involved in this project. So we're just two of them. Here you can see a short agenda. Our plan is that this webinar will not be more than 60 minutes. Yeah, we hope to keep the time, and yeah, we will go now directly to the presentation from CERTH. Yeah, I think we mixed a bit. We will present the CIRCE role in Renaissance when we start our presentation. I have it here at the beginning. We'll just put it together, not switching too much the screens. So now, Nikos, we could do this switching. Can you share your screen now?
No, Hans, I will start, but so Nikos will come after. So I will share the screen and I will.
Okay.
Run it. Can you see the screen? Hopefully. I think everyone should be able to see my screen by now. So we will explain a little bit the need in making the energy greener. Here we see on the right the global greenhouse gas emissions produced, in which energy is accountable for 73.2% of the total CO2 equivalents produced worldwide. And when we refer to energy, this is clustered in energy used in buildings for heating and electricity, energy used in transport, and energy used in industry. All of these three clusters present a very big participation in the production of the CO2 equivalents. And on the left, we can see what the CO2 equivalent for each sector is since 1990, and the amount they have been producing in billion tons of equivalent carbon dioxides. We can see the progress, especially for the electricity and the heat, is going steadily very high, especially recently throughout the years. And if we look a little bit closer for the transport sector, here we have a very interesting graph which shows the correlation between the greenhouse gas footprint of the electricity grid and the life cycle emissions of each vehicle. We can see that if the greenhouse gases footprint of the electricity grid is about 700 grams of carbon dioxide equivalent per kilowatt hour, then the battery electric vehicles have the same life cycle emissions as the gasoline internal combustion engine vehicles. And if this number gets to 600, then the battery electric vehicles have a higher life cycle emissions than both gasoline hybrid electric vehicles and plug-in hybrid electric vehicles. And last, if this number gets to 370 grams, then we see a break-even point between the battery electric vehicles and the hybrid electric gasoline vehicles. So we hear that everyone says that electric vehicles is the future of a sustainable transport, but this is not quite true. It is not just in electric vehicles. Overall, such life cycle analysis confirm the need to accelerate the decarbonization of the power generation sector, and clean electricity production must be coordinated with other sectors in a coupling process to produce a decarbonized electricity. Next, Renos, please, if you can explain us this diagram here.
Thank you, Aristotelis, for giving me the floor. On top of what Aristotelis has already added, in this slide we focus on the importance of the local energy systems in the process of energy transition. Such systems involve the so-called distributed energy resources, which combine distributed energy generation, storage and demand management. Looking to the future, electrical local energy systems or else microgrids could form even the entire grid. Moreover, recent legislation on local energy communities has enabled the potential for social and financial benefit for the local communities. Thank you.
Okay, thank you, Renos. Thank you, Aristotelis. It's Nikos Katsaros from CERTH ITI. Now that we saw the main challenges, it's time to introduce the project and how it manages to address them. So, Renaissance Project is an innovation action which whose purpose is to provide an implementation approach regarding business models and technologies that are able to support both clean production and safe distribution in local energy communities. Among its main objectives are the identification of stable and equitable business cases for local energy communities, the design of business models for renewable local energy systems, the development of a platform towards the integrated management and value delivery across all the actors within the project, the demonstration of energy communities and systems with more than 27% renewable energy sources integration, and also the leveraging of the approach to up to 10 sites across the globe under market conditions. Next slide, please, Aristotelis. Our organization role in the project, CERTH, will be explained in the following sections. CERTH, or Center for Research and Technology Hellas, is a leading research center in Greece. It was founded in the 2000s. Its main research fields include climate change and sustainable energy, artificial intelligence, robotics, and IoT, many approaches to healthcare and nutrition, autonomous vehicles, smart cities and circular economy, and many others. 5 research institutes comprise CERTH and occupy in total more than 1,000 people, mainly engineers and scientists in 6 different regions and 7 different cities. And also currently CERTH is ranked as 15th among the EU research centers regarding the Horizon 2020 net European contribution, but also it is first in Greece among the most distinguished European research centers. Our role in the project is carried out by 3 out of the 5 institutes, namely the Information Technologies Institute, ITI, the Hellenic Institute of Transport, and the Chemical Process and Energy Resources Institute. Our tasks include the development and application of models of energy systems for dimensioning or topology design purposes, the development of software solutions for local energy systems towards energy intelligent management as well as energy trading, and finally the development of tools and visualization interfaces towards consumers and prosumers engagement, which are provided in the demonstration activities of the project. Thank you.
Okay, I will share my screen now. quickly. So, hello, here's Hans again. Just quickly, who is CIRCE? We are like a bit more than 25 years old now, doing R&D services for companies, the society, and the environment. Not only, so it's not only for companies. So we are a technology center founded, there's missing a letter, in 1993. And yeah, we are seeking to provide innovative solutions for sustainable development. This is a wide field, so we are working on many different topics. We are more than 268 professionals right now, recently growing quite fast due to the recent developments, urgent acceleration from Europe for this kind of investigations. So, give a summary of CIRCE's purpose. We try to even anticipate the needs that some company or anyone could have, and then do the technology transfer for the solutions, focusing on the sustainability and competitiveness. So yeah, we are proud of having a lot of these ISO certificates. So this is important to guarantee the quality of our work. So I don't want to stay here too long. Important, we are working on 6 main fields, which is renewable energy in general, any kind of renewable energy. Then we call it future electric grids. This is smart grids, but also studying how renewables can be integrated in the network. So this, here I see I made a mistake. I did not, so I have to do it here with for my mind. The field 3 is electric mobility. The field 4 is industry 4.0, so it's modernizing the industry. Then energy efficiency is a big field, and finally mainly circular help me circular economy. Sorry. So now I did something. So yeah, I think this
Yes.
is now. Yeah, I think I made a mistake when I prepared this presentation. I will just jump to the good part here. So, sorry.
Hans, I think later after maybe we
Yeah,
should,
as I started
maybe
here,
we should take your part where you present the CIRCE and take it before we start.
Okay, as I thought I would give it later, and then these slides were inside,
Okay.
and I started, and let's just go on over this.
Okay.
Here, this is a good slide. Future electric goods, smart mobility, industry 4.0, energy efficiency and circular economy, sustainability. So just to show you, we are working in Europe, of course, but also of mainly on Latin America, but also in other parts of the world. We have collaborations with companies and other institutions. Our headquarters in Zaragoza, Spain, but we have also a delegation in Madrid and Brussels. Within Renaissance, our main contributions one hand is a small device, we call it the energy box, which is a multi-purpose smart controller able to manage smart devices in any environment. My colleague Juan will later explain a bit more about this.
We're not watching the slides.
Yes,
Oh.
I think you're not sharing this this time because I think I have the red frame.
Yes, now we can see it. That's correct.
Yes, right now, yes.
Sorry. Oh, I will start again. So we'll cut it out. Start
No
again.
problem,
Okay.
no problem.
What,
We could
what
see
is,
it anyway. We heard you.
Yeah. Okay. CIRCE is working these 6 fields: renewable energy, future electric grids, smart mobility, industry 4.0, energy efficiency, and circular economy. Here now, you heard it before. Now I have the picture. We are working with people from many places all over the world. And here the first photograph of our energy box. Juan will later explain a bit more details. Within the Renaissance project, this energy box had been adapted and improved, and mainly to be able to participate in transactions via smart contracts and energy services. The main work we are just into right now is the validation of the Renaissance platform. There comes in our living lab, which will be explained later also. Here, CIRCE is providing its scientific and technical knowledge. We lead this validation task, coordinating several partners. And finally, with this living lab, we are emulating a pilot site to get this end-to-end testing, which we will see later. So now it's your turn again.
So it's I think, right?
Yeah.
Let me
Sorry
share
for
it.
this small confusion.
Hello again. Hope you can all see my screen. I'm Aristotelis Pliotis again.
Aristotelis, could you remove me on the?
No, wait.
And,
From the
and get the full screen. Yeah, if
yes.
you can remove my face down
wait.
the right. Okay, perfect.
Hello again. I'm Aristotelis Pliotis from CERTH. I will present you the Renergize tool. Is one of the tools that CERTH has developed in the context of Renaissance project. So this is a computational tool for the participation in future local energy systems. It is a tool intended to assist the potential users, the customers, the future customers of Renaissance, to assess the benefits and the costs of being actively involved in a local community, energy community. So we see here how this works. Any user can use this tool. It comprises of a front-end interface and connected to a back-end multi-vector tool. So the user needs to put as an input environmental, technical, and financial values, and receive as an output the energy cost of the concept system that they have built on this tool, and also assess the efficiency and the performance. So everybody can access this tool from the link presented on the bottom left on the screen. It is a web application, so it is easily accessible from everywhere and any kind of terminal and smart device. So here we see schematically how this process precedes the participation of the user. So any potential user that wants to engage in an energy community can access the tool. What they need to put as an info is the site information, the financial information of the local site, add the energy assets that would like to be installed locally on their premises, and then add an energy profile consumption. What are their energy needs, their personal energy needs. So the tool takes everything into account, gives out the results, and then the user can take their decisions. Maybe they can change some of the assets to see which one presents a higher efficient rate and which one not, and even decide about their overall participation in the system. Here we see about the Energize tool, which we said it comprises of two parts. We have the front end, which has been developed through Visual Studio Code and generated through Angular CLI. It is a dynamic web application compatible with all major browsers in every operating system. And the browser's developer tools have been used for debugging issues. We have incorporated a Google map used to retrieve locational data, and the Postman platform used to validate the HTTP requests and responses. As for the design elements, we have developed this through a user-centered approach and a user journey map to achieve a more user-friendly navigation. On this figure right here, we can see how we have set it up, this journey map. It is not very clear, but if someone is interested more, you can follow this link and examine the whole process. And then we have the backend, which comprises of two services. We have the Python Flask REST API to handle the three different storage models. We have the user profiles, the projects, and the energy assets added by the user. And then we have the Python salary job scheduler to handle the weather data, the world coordinates, and solve the energy scenarios. And these two backend services are connected through a Redis database. So if we need to take a closer look on the required input, the user needs to know the location of where they would like to install the energy assets. For this, you can see on the screen, we have also included the Google map, which makes it really easy to locate it and add the coordinates. They need to know the financial information locally, as it is the interest rate and the price they sell or they buy the electricity from the grid. Here we have to mention that in the future this might be updated automatically by the market. And then the user needs to add up all the required energy assets. This is done through, as we see from the interface on the right, the different tabs represent the different assets they can add. They have to add the consumption profile, the public grid characteristics, and then they can choose at least one of energy assets from the battery, the gas turbine, the charger for electric vehicles, a solar photovoltaic station, and a wind turbine. Here we can see the kind of the information required for each asset. And of course, we have also included some default values filled up based on the location of the user by default, which are not very accurate, but they can give a first outlook to a user who is not very advanced in energy technology. Here we can see the results of the tool. they are in two parts. First, they present on the right the total results of the system. So they provide information about the total cost of the installation and every system that the user has decided to install. And then we have the efficiency and the electric output of this system. On the left, we see the graphs produced by the tool, where the user can choose a time frame. It could be monthly, daily, or yearly, and each asset they have added to the system, and check out the efficiency and the output of this asset, particular for this time frame. Another very important feature of this tool is the user can save, they can store a concept energy system locally, and then they can use it as a template by duplicating this energy setup to create another one, or save it for later and compare two projects to one another, as we see here on the figure, where we have the comparison of two different energy systems, and the values on one assets which present lower efficiency than the other are marked with red. And also this feature has been integrated in the graph section, where we produce two different graphs for the two different systems. Then again, the user can choose a specific time frame and asset to compare from the two systems. This tool has been validated in Renaissance project in two rounds. We had the technical validation, which was done using the unit testing and the SonarQube application. Secondly, we extracted the user experience and user acceptance with the aid of questionnaires created for this purpose. We actually had some very good results, and we would like to ask anyone who wants to test these tools to later fill in these questionnaires using this link, which you can see right here, so we can get your feedback and even get the tool better. So thanks. I will give the floor to Renos.
Thank you, Aristotelis. Very nice. Hello, everyone again. As already mentioned,
Reno, I'm very sorry. Can you share it so I can?
Yes, of course.
Sorry. I can also mute.
Yes. Can you see my screen? Let me know.
Yeah. Yes. I see it.
Okay. Hello again, everyone. As already mentioned, I'm Renos. I work for the Chemical Process and Energy Resources Institute of CERTH. And through the next slides, I'm going to share with you our experience from the conduction of dynamic simulations of the local energy systems of two energy communities of the Renaissance project. Namely, these two communities are located in Chimeria, Greece, and Manzaneda, Spain. First of all, let me introduce you to some basic concepts of our approach. What we do is dynamic modeling of energy systems. What we focus on is the accurate prediction of the evolution of system quantities in time under varying external conditions such as weather or user behavior. The way this is done is through models that combine multiple mathematical relationships that are being solved by specialized software. However, there are some challenges arise and have to be solved in order to proceed with model development. First of all, a technical background is necessary. Also, in most of the times, sophisticated software must be used. Big effort as well may be spent to develop and build proper and meaningful processes and outputs. And also, usually the models that are being developed are case-oriented. So with this in mind, in this slide, we present the application of our approach in this study. We want to have an in-time representation of the Greek and Spanish Renaissance local energy systems. We also need to want to examine the interactions among the energy vectors and come to conclusions on best practices in terms of system energy performance. For example, we must identify the operation strategies that lead to the maximum contribution of renewable energy sources. Next, in this slide, the methodology that has been followed for the building of the models of the two communities is described. Actually, it takes place in 3 stages. First, the specification of the actual system. Second, the development of a validated system model. And third, the definition and evaluation of alternative scenarios. Next, we move forward through a quick overview of the key assets of the Greek local energy system. As you can see on the left side, the local energy balance involves solar, thermal, and photovoltaic energy, biomass, organic ranking cycle, electricity generation, absorption, refrigeration, as well as both thermal and electrical energy storage systems. In this slide, you can see the computer-aided representation of the system. Excuse me. Models have been designed for all of the system components already mentioned. On the right side, you can see also the model of a non-site geothermal system. In the next slide, the main energy assets of the Spanish local energy system are listed. The system involves photovoltaic energy and biomass, as well as 2 types of battery systems. Yes, a second life and a new one. Should we mention that the second life battery has been previously used in an electric vehicle. The thermal and the electrical grid models of this system are shown in these 2 figures. You can see that all system points from energy generation to the final consumption are included. We move forward to the following question: which are the outputs of this procedure? On the left, you can see some extracted results. The case under study is a weekly operation of the Greek site during a sunny week in July. At the top figure, we are able to see the power flows at each time point. For example, you can see that the battery system absorbs the excess energy generated by the photovoltaics and or the organic ranking cycle generator, and injects it, and later on injects it into the grid when necessary. Below, the corresponding values of battery available energy level, also known as state of charge, are shown. Of course, this is just an indicative demonstration, since the time scale and the monitored quantities can be selected in any other way. Finally, if you found our approach interesting and want to learn more, we would be really happy to have a look at our publications throughout the Renaissance project. They are easy to access, and you can find them at the project's website. Thank you, everyone. I will now give the floor to my colleagues, Nikos and Zoe.
Thank you, Renos. Great. So I believe you can see my screen now.
Yes.
Me and Zoe now will present CERTH ITI's contribution in the Renaissance project. We will describe the design of novel energy markets, which is the participation of local energy communities in the energy trading via blockchain. So a few words regarding energy trading and blockchain. The energy trading designed for the Renaissance project has been built on a permission blockchain, which guarantees privacy and increased security. This means that the participants, who by nature don't trust each other, can securely perform transactions. All transactions are being recorded in an immutable transparent ledger, and the marketplaces that we're going to describe in the following slides have been based on smart contracts, which on the one side automatically enforce rules and agreements, and on the other side guarantee the transparency and security of all the involved transactions. In short, this means that every household which is a part of a local energy community can convert into a small business that can profit from energy trading. So without further ado, let's see the marketplace is designed. The first marketplace is the peer-to-peer one, which actually allows for energy trading among different local energy community members. It is important to highlight that no intermediary bodies are required, thus the profit for the LEC members is direct. Its participants just need to be registered in the platform and have a sufficient amount of money to participate. The bidding is competitive, which means that winners are automatically detected. So the fair competition between all the participants in the platform is reassured. The bidders can always submit better bids in any auction, and they can also set and the LEC members can also set their own prices as long as they follow the set boundaries for the billing and the energy trading. Of course, the winner of this auction always gets paid or pays according to the type of auction. Moving to the load demand-side management marketplace, this one actually allows the distributed network operator to harness the flexibility of prosumers or consumers in the local energy community. He or she can actually request LEC members to either increase their consumption or inject energy to the grid in order to ensure its stability in terms of voltage, frequency, and other parameters. So multiple members can actually participate in this auction. So more than one member can be winner in order to meet the grid's energy needs. Similar to the marketplace that we described earlier, the members are competing and also can improve their bids, both regarding the energy provided or consumed, and also their monetary compensation. The main differentiation in this marketplace is that in case of energy flexibility not meeting the agreed terms in its auction, the members are penalized monetarily in order to ensure that all bids made actually represent real actions later. In order to ease the participation of the members in the aforementioned marketplaces, CERTH has designed an intuitive user interface, which where the users are available to register and create a virtual wallet in order to allow deposits or withdrawals of cash. After completing the registration, the users can see the active auctions in real time and participate by placing or updating the bids, as we described. Users are also able to see the overall infrastructure life status, as well as historical data and predictions regarding energy production and consumption. Where possible, they can also remotely control electrical loads under their possession, and to access the Renaissance social platform and also the award-enabled service. Now we are going to see a short demo of the platform. So now we'll give the floor to my colleague Zoe.
Hi everybody. So since we do not have much time left, I'm gonna quickly show you some capabilities, let's say, of our platform. So the platform is the user interface, the way that each prosumer or consumer can interact with all the developed tools. So I guess most of the attendees are new to this idea. So let's say that I am a new user that I want to participate in a local energy community. So all I have to do is just to register. So we have, for now, 3 local energy communities developed under the scope of the Renaissance project. These are the 2 demo sites, Kimeri and Mathanedan. This is our LEC, CERTH LEC. So, you know, it's a new user can just quickly put all the necessary information and create an account. I'm not gonna do it for now because we have already created a new account. You know, let's select our energy community. At this point, maybe clarify what's a prosumer. The prosumer is a user that has the capability of also producing energy by renewable energy sources, and not only consume. Those who only consume called consumers. So I'm logging in. Let's say the password. So this is actually the menu tab. So this is the view that each member of the local energy community shall have. So in the account, you know, each one can see the e-wallet that it has. One of the novelties developed under the scope of the Renaissance project is this e-wallet built upon a blockchain for security and transparency, as Nikos described before. Our goal is to not only create local energy communities, but also to have business models that, you know, small players, small prosumers can participate, not only big ones, because today's business models, that's all about big This is the user that we have logged in as our CERTH smart home, and it's the photo in the introductory slide. So yes, I'm a prosumer. I have this available amount in my e-wallet. That's some details about my facility. So we have power generation, consumption, storage capacity, which is our battery, and of course EV chargers. I will show you next. Let's take a look at the marketplaces. Oh, sorry. These are some transactions that have been made since we made this create actually this user. These are some upcoming events, so auctions that are going to take place in the future. These are the completed events. Just to clarify that all of this concept was based on the model of English auctions. So I say that I have an X amount of energy that I will not be able to use. So I'm going to give it to you, to the rest members of the local energy community, and so who wants to buy it. And the most competitive bid wins. So for example, here I was a winner in an auction, in a past auction. So you can see here the bids that the user has, the auction that can create, and of course some information about the marketplaces. These are the main marketplaces that Nikos described before. Of course, we have developed some other marketplace scenarios that involve also the DNOs, the distributed network operator. So yes, I think we ran out of time, so that's a short glimpse of the platform. But of course, should you have any questions about that, happy to answer them and give you a more view of what we have developed. Thank you for your time. Hans, back to you.
Thank you very much, Zoe. Yes, I think now Juan can take over. Are you there?
Yes, I'm here. So
Okay.
Okay. Hey, sit. Okay. Okay, I'm going to explain a little about our development in the CIRCE facilities. The idea is to take our office for testing the different marketplace implemented by our college Ikerland in the blockchain platform. So for the purpose, we have in our facilities the energy box, a different automation systems like concentrator switches for the lights, for the control of the temperature, the different sensor of presence, smart meter for grid analyzer and monitoring all the consumption of different climates and lighting systems. We have different EV chargers and PV and batteries. For control of our office, we have the energy box. Okay, is implemented for the automation control of the office with different communication with module devices, with the grid analyzer, with PV control monitoring, with the battery and different EV chargers. And we have implemented the communication with Renaissance platform. We for use the office like a demo case, we have implemented that all the consumptions of the different devices of thermal lights and climates, it can be simulated like, for example, like an actor with a consumer actor, and upload all the information to the Renaissance platform, and it actuator like a consumer. So we have different devices, how I say before. We have an SCADA for control monitoring all the devices, and we can control different types or size and a very amount of devices, like 19 grid analyzer, 33 thermostats, a large light control presence detectors, okay, and PV, battery, and vehicle electric. So our hardware is compact and modular. We can implement different software. We can use different software to like a third-party software, and we can implement low-level algorithms for that purpose. Well, this is our PCB that we can use Zigbee devices. We use a commercial Raspberry Pi. We use Wi-Fi and different another communication. Okay, and for test the communication with the Renaissance platform. Okay, we have test two different markets. The first is the energy social supplies. Like that I say before, we have virtualized the consumption of different zones of the office, like if they were a consumer. So, for example, if a zone in the office has a consumption of the thermal, we say that is actual like a consumer in the first market, like a student. Okay, and we have implemented a user interface that our colleagues Gonzalo explain in detail after. And the purpose is to communicate and to test if all the communication between the different models is correct. For example, in the unified IPA is implemented by our colleagues from Atos, and the blockchain is implemented from Ecoland, and we want to try if everything is function correctly. Okay. So we have test the first market in the energy social supply, and in the second energy market is the peer-to-peer version 2 that we upload in the energy box, upload all the information to the unified API in the Atos platform. Okay, we or in the Smart Oracle is work with the data for test and validate all the information. We can implement, the idea is to implement an actions, and by the different users, consumer, can be bits and can distribute all the token finally by the Smart Oracle. Okay, the idea is to enter in the system like different roles, like a producer, prosumer, consumer, or the administrator that manage users and the markets, and the different roles can do different sections. Like the producer can create an action, another role can make a bid and an action, and finally the action is implemented. The winner take the tokens and is distributed. Okay. The main system works in 15 minutes. It's implementing an action, and everybody can bid. And in the next hour, the actions for the administrator of the energy or something like that is served to the system, and in the final of the day, the smart oracle take a report and pay the seller and the bills to the consumer. Okay, and Gonzalo, if you want to take the control, you can explain us how it's implemented.
Okay, fine. I will share it. Okay. Are you watching my screen?
Yeah.
Okay.
Yes.
So, as Juan said just now, we're going to look right now the validation results of the implementations of the markets. We're going to look them via a user interface implemented by with the Angular framework. And first, the users are managed by Kcloak that manage the login and the different roles for the users. And first, we're going to look the part of the energy supply. There are two types of roles in this part: the administrators and the tenants, that are the users that can use the application also. When the administrator login in the application, they can see the home, that is the supply market, with the market name, the different sources, energies, and the prices for the biomass and solar thermal in this case, with their cap IDs, and also can see a graph with the tenants if they are paused, waiting, or monitoring. They can look the users table with different attributes for the different users. Some of the attributes are taken by queries to the Atos system, and others to the blockchain managed by the MyIkerland. And the administrator can create new users as students, that they are the tenants or the administrators, and can set some status like monitoring or waiting or pause. When they create the users, they have to set the attributes like the initial icons, the cap ID for the student, and other like username, email, and all of this. And after created, they can see them in the table here, and they can edit or delete the students, do all of this. When they edit, they can see again all the attributes of each user. And then the students can also enter the tenants in the application to see their report, their status, the icons that they have, and the energy consumed in a period of time. All of this is managed with the explanation that Juan did before. And that's all for the first validation of the use case, that is the energy supply. In the second, there is the peer-to-peer market. As before, we have the administrator that can manage everything in the application. The users can see the market and also the auctions for the market. I didn't pass slide. Okay, right now, yes. This is the part for the P2P administrator. When they log in, they can see the markets. For now, we only have that one. The market is defined. Okay, sorry. In the market, we can see the mean price or the max price defined for the auctions that comes into the market, and also if the market is open or closed, and the auctions that every market has. This is the auction page that we we're going to see later better, but in every auction we can see the bids made by the consumers. And as before, this administrator can manage the different users that we have in this part. When they create a new user, they can choose a role. As explained it before, the different roles are admin, consumer, producer, or prosumer that has the ability to be a consumer and producer at the same time. I paste the page again. Okay, so when we create a new user for this part, we can select the PV power, the cap ID, and the initial ecoins that we can give to this user. And after some seconds, he's registered in the blockchain, and we can see him in this table. Okay, so now we change it to a different user. As we can see here in the top right part is the prosumer. The prosumer can create new actions. As we can see here, the actions have some attributes like the energy supplied, when it starts and when it ends. Also, the start price is a max price that can have the bids inside, and when the contract starts and the duration. The auction starts always at 45 minutes, depending on in each hour that they decided, and it lasts until the new hour, so it's 15 minutes, and then the contract will start after that auction finish. So when the administrator create the new auction, is defining the market mean and max price by the market. The power is made by not the administrator, sorry, by the prosumer or the producer. And he can select the start price and the desired price for this auction and select the auction start time. Here we can't see it, but there is a calendar that appears here to select the hour. And after he chooses the time, as I said, is until 45. It starts at 45. It lasts 40 minutes until the contract will start, and the duration will be 1 hour. And after we create it, it appears here. And if it's between the time right now, the auction will appear open. And now with the consumers entering the application within the time that the auction lasts, they can make some bids to win the auction and get the power supply. Right now we log in with consumer 1. The market is open and the status of this auction is open also. So he can enter in the dialog and add a new bid for this auction between the start price and the desired price. He made a new bid right now, so he appears here in the table. And if another consumer logins between that hour, he can also make another bid superior to the last one. And if it's the last bid after the auction finish, he will be the winner. So here the consumer 2 is creating a new bid. And we can see it here that it's registered well in the blockchain. And if it finishes like this, the consumer 2 will be the winner for this auction. So here is the validation for this second use case. Hans, do you want to change?
Yeah, thank you very much, Gonzalo. That was the last part of the presentation. I don't have anything to add. Thank you very much. Just to summarize this user interface, of course, in a real application, a user will not do this manually each hour, doing the bids, but the objective of this interface was to validate all the communications with the Renaissance platform and the blockchain platform developed by Icala. So what Gonzalo just showed was actually this validation that these communications are working correctly. So thank you very much to all to be here, to give us this nice presentation. I think I will just share finally the presentation to have a nice final picture here. So thank you very much to all, and I hope we will have a lot of people looking at this video, and we will share this very soon on YouTube.
Thank you very much, Hans. Thank you all. And yes, I confirm that the video will be uploaded very soon on YouTube, and we will also give some space for questions and answers there. So every comment that you want to add will be addressed by CIRCE or CERTH, depending who you are addressing to your question. I would also like to see if there is any question here now. Maybe if someone wants to ask something, we might have 4 more minutes. Or just simply stop here and then collect questions, either via email or through comments to this video. Anyone?
No question from my side, so it's everything quite clear.
No question, just something to add to what you just said, Rebecca. Even if not now, we have to stress that every tool includes an email and a communication form, so the users can feel free to ask any question anytime they would like.
Great. Thank you. It was very interesting and a learning opportunity also for me. And I hope you enjoyed it, also preparing and organizing it as we did. Thank you very much.
Thank you very much.
Thank you all. Thanks.
Thanks.
Bye.
Thank you, everyone. Goodbye.
Bye.